Hello everyone, this is Jovis Claveria and my co-author is Professor Akhtar Kalam. We are from the College of Engineering and Science in Victoria University, Melbourne, Australia. This presentation was already presented in Australasian University's Power Engineering Conference or the OBEC 2020 in Tasmania, Australia. The Communication Information Security Assessment of Digital Substation is more on an international standard defining the communication protocols for intelligent electronic devices at electrical substations. The outline of this presentation includes aims and significance of the research, the different types of communication protocol standard, the overview of the Victoria University Zone Substation, the VUZS simulator, the VUZS protection and control scheme for the IEC 61850, that's a communication network, application of security measures in Victoria University Zone Substation, includes IEC 62351, that's the data and communication security, the safety assessment method for power systems using the GOOSE, MMS, and SV, the message authentication code methodology using Wireshark and Python, and the last one is the conclusion. The research aims to develop new strategies on power systems. First, we have the substation automation, the grid communication, and cybersecurity solutions. It is based on the following standards, and these standards are the IEC 61850 and then the IEC 62351. The IEC 61850 covers the communication networks and systems for power utility automation, while the IEC 62351 covers the data and communication security of IEC 61850. The specific aims of the research can be summarized as follows. We could use the VUZS simulator as an integrated testing facility for other power utilities who wants to simulate for research purposes. The other ones for the review of communication protocols on IEC 61850, we have the GOOSE, MMS, and SV. These are the acronyms used for the entire research and presentation. The use of IEC 62351 standard, this is security handling of IEC 61850 communication protocols. The most common IED communication protocols that have found widespread use in the substation environment are Modbus, DNP3, IEC 60870, UCA, and IEC 61850. The Modbus protocol was initiated by Modicon. Basically, a Modbus at least must have a master device and a slave device to operate. The device requesting for the information or signal is called the master, while the slave is the device supplying the information. The distributed network protocol was originally developed by Westronic. It is also a master-slave protocol platform, and it is popular in North America. While the IEC 60870 standard was developed for protection and control of SCADA and associated telecommunications. It is famously used in European countries. The Utility Communication Architecture, or the UCA, is a standard protocol that was recognized all over the electric utility industry in 1988. It shows the successful integration of different electric utility enterprises that facilitates the integration of communication protocols and form the basis of the IEC 61850 standard. The international goal is to agree on a single standard, and IEC 61850 standard was born. It was launched in 1997 to develop a communication protocol for substation automation. One of the significant achievements of the IEC 61850 standard is the GOOSE protocol. Its GOOSE signal has specific details, namely the GOOSE ID, MAC address, virtual local area network priority, dataset, and data attributes. This makes it recognizable in the network. If you could see it, the GOOSE can group a data set and transmit substation events like signals, alarms, and commands in the form of a message. And this is used for time-critical events, for protection of electrical equipment, and exchanging between devices by means of a local Ethernet network. And did you know that the speed of the GOOSE signal reaction time is less than 4 milliseconds? That's so quick. For the communication stack mapping shown in the figure, the GOOSE and SV protocols are being mapped directly via high-speed messaging on LAN through Ethernet. So the network transmission implies that data messages carried out are of a high level of importance, such as time-critical protection, relaying, interlocking data between IEDs, alarms, signals, and others. So both GOOSE and SV are under the layer 2 multicast, which means that it skips other data and communication layers for immediate processing. While the MMS is present in most devices for operational reporting and monitoring functions, MMS is not of high importance. So IEC 61850 standard defines a communication architecture ranked into 3 levels, and these are the station bay and process level. The station level is used for archiving information, monitoring data storage, control operations, and management software tools. So this level carries information from SCADA and protection relays from bay level, and the devices present on this level are station computer, HMI, SCADA, system, and RTU. For the bay level, it consists of different IEDs. So the IEDs can make local control decisions, protect irregularities from the process level, transmit data to other IEDs, or send data to the substation SCADA for further processing and monitoring. The process level contains devices such as circuit breakers, primary and secondary switchgears, actuators, and others. So this is the measurements coming from the different parts of the substation. This figure illustrates a typical substation architecture for Australian substation, but there are still power utilities that are not willing to migrate to IEC 61850. Maybe because they are not comfortable with the new technology, or they need to train their personnel about IEC 61850, or they don't like to upgrade because their substation is still working fine. Who still remember Nokia company or Nokia phones? You know what the Nokia CEO have said? We didn't do wrong, but somehow we lost. This means that we need to embrace new technology. We need to embrace challenges for sustainability. If you remember that Nokia, they are on top of their games. No other phones have the qualities of the Nokia phones. Victoria University has been a pioneer in providing trainings and workshops on IEC 61850 standard in Australia. As a result, Victoria University develops training modules and projects to implement, configure, and test portable simulators, whose sole purpose is to serve a platform for development and training of university students, researchers, and power system personnel. Here are the portable simulators VU had produced. We have the multi-vendor IAC 61850, the portable testing unit, and the second one improves to SCADA systems and fault simulation on substation. And the new and more complex, the Victoria University Zone Substation simulator. They are built as one. So the communication arrangement of the VUZS was based on a zone substation in Australia. The VUZS simulator has its limitation. It will focus more on the station bay level for the transmission of GOOSE and MMS protocol, while the sample value on the process level will be produced by some test devices just like Omicron, Dobel, and digital equipment like Opal RT and RTDS. And this will emulate the characteristics of CTs and VTs in the substation. The application of security measures. So security measures for GOOSE and MMS between the station bay level, and the security measures for GOOSE and sample value is between the process level and bay level. There are simple security measures and techniques that can be implemented inside a substation environment. For instance, personnel working the station level must be knowledgeable in computers and knows the substation process. The personnel working on SCADA and HMI must be properly oriented and must abide with the security policy of the organization. An inclusion of graphical user interface for measures like biometrics and others will make computer access more protected. On the side of operating system, the Control-Alt-Delete combination keys is called a secure attention key. Cyber attacks and threats are not restricted to government infrastructure, power utilities, and large network organizations. However, these threats and attacks can be intentional or unintentional, but it can be coming from, but not limited to, the following sources, just like for espionage, political activism, unintended mistake of employee due to lack of training, recreational hackers, criminal groups, internet threats such as viruses, and others. If you remember the infamous 2015 Ukraine power grid cyber attack, how did it happen? It just started from phishing email. Then the personnel opened the email and clicked the links attached. Then the attacker controlled the SCADA, remotely switching all the substations, disabling the interruptible power supplies, and others. So this was a huge loss for Ukraine. So we have the safety assessment method for power system. We have the fault tree analysis. What is this fault tree analysis? It's a type of analysis based on possible sources of faults or accidents that lead to system failure. This is already a fault. Analyzing a fault from it looks like a tree. So if the power system failures, you need to go down. This is the top or bottom analysis. So check if there are different types, just like the failure, what type of failure, is that the protection, the power feeder, and everything. And the next one is the attack tree analysis. This is type of method investigating an attack using a conceptual diagrams and modeling a threat in a system. This is from the bottom to top. So if I am an attacker, I need to check on the different types of an analysis from that attack tree. How to go to my goal. And that goal is to open a circuit breaker. That's the attack tree analysis. This is how a GOOSE message is being processed for MAC authentication with secret key. The sender IED will send a GOOSE message to a MAC algorithm and will generate a secret key. The GOOSE message and the new generated MAC are sent through an Ethernet link to the IED receiver. The IED receiver will also generate its own MAC with the same key from the IED sender. If the MAC of the receiver is the same as the sender, the GOOSE message will be processed accordingly. Otherwise, the GOOSE message will appear to be tampered during transmission and will be discarded. The Wireshark software will be used to analyze the packets from the communication protocols, GOOSE, MMS, and SV. The packets of the GOOSE message will be monitored from the physical ports of Ethernet and wireless network. The Wireshark Network Analyzer shows all the specific details of a GOOSE message, like GOOSE control blocks, time allowed to leave, dataset, Go ID, timestamp, status number, sequence number, and the different data entries of a GOOSE message. The MAC value authentication will be written using the Python script. It will contain the data and code for secret key generation. When using the MAC algorithms for authenticating the GOOSE and SV, the digital signature is replaced by MAC value in the extension field of the GOOSE SV frame. So the total bytes of the GOOSE message will increase. The IEC 62351 standard is still in its infancy stage in handling the communication and information security of the IEC 61850 standard protocol. The GOOSE, MMS, and SV are critically vulnerable during transmission and application of messages across the substation. To further address the security challenges, a case study was initiated to illustrate the importance of fault and attack tree methods in effectively mitigating intrusion and detecting event anomalies in the substation. Furthermore, an authentication method for MAC was also projected in generating a secret key using a Python script which contains data and code. For packet analysis, Wireshark was chosen due to its popularity and capability for various statistical packet analysis in a network. That's all, and thank you for listening.